Competency based questions. Chapter Coordination Compound. This is for your upcoming CBSE board exam 2025 chemistry. So this year they already announced that 50% questions will be based on competency type, right? So that may not be direct questions. So instead of direct, they will make some twisted questions in the section A, section B, any area we can expect it, mostly in the MCQs part. So dear students, welcome to Brilliant Qatar. Let us discuss the questions from the chapter Coordination Compounds. Ready? So question number 1 for you. A coordination compound pentaamine. So they given a coordination compound here. Let me write that compound pentaamine. What is mean by pentaamine? NH3 5 time, right? Pentaamine chlorido. That means chlorine is there. Cobalt is the central atom. And sulfate SO4 is the counter ion. Ready? Question is dissolved in, and see the oxidation state is 3 or not. Please check it, all of you. Yes, right. Cobalt X, amine 0, chlorine -1, sulfate is -2, overall 0. Yes, X is equal to +3. Correct. Here the coordination, the cobalt central metal atom is in +3 oxidation state. That's correct. But here the question is, when a few drops of chemical A, is added to this solution, it gives white precipitate. Identify the chemical A. You may study that if sulfate is the counter ion, when it react with the barium chloride, BaCl2, right? Barium chloride. What happened? Ba combined with the SO4, you will get white colored barium sulfate. What is the color of the barium sulfate precipitate here? White in color. So what is the compound is the question. What is the chemical? That is barium chloride. See, if sulfate is the counter ion, if it is treated with the barium chloride, you will get white colored barium sulfate. You may study this one in the ionization isomerism part. Ready? Question number 2 for you. How many ions? All right. How many ions will be produced by the complex? One of the simple question. En thrice and Cl thrice. How many ions can be given? Very simple. The complex, you know, the coordination sphere do not break. So coordination complex is 1, counter ion is 3, total will give you 4 ions, right? So we can write the ions as CrEn thrice, 3 plus and 3Cl minus. Total 1 plus 3, 4 ions can be produced. So answer is option B. Ready? Question number 3 for you. Dear all, listen carefully. In the complex is given as what? Fe4, FeCN6 thrice. Have you seen this compound in any of the topic in the chapter coordination compound? It is there in our last topic, that is what? The qualitative analysis. To check the presence of ferric ion Fe3 plus in a compound, we are treating with the K4 FeCN6. We will get this Prussian blue colored compound Fe4 FeCN6. All thrice, right? Here the question, what is the oxidation state of counter ion Fe, and the central metal ion Fe respectively are? Do you remember what is the name of this compound here? The name of the compound is iron 3. The counter ion Fe, its charge is 3 plus. Iron 3 hexacyanido, ferrate 2, right? So the counter ion, it is in 3 plus oxidation state, and the central metal atom is in 2 plus oxidation state. So what is the answer? 3 and 2 is the answer. That is option B. Okay, so very carefully study the last part is there now. Which one? Qualitative analysis, quantitative analysis, biological systems, cisplatin, etc. Wilkinson catalyst. Please focus on each topic. Since it is a competency based questions comes for your exam, each topic we should be thoroughly studied. Question number, when a coordination compound is dissolved in water, it produces 3 moles of potassium ion. Okay, so potassium ion. So there will be 3 potassium outside. That's the meaning. As cation and 1 mole coordination entity as anion. the central metal ion is Fe in entity is surrounded by 3 didentate anionic ligand, which is the didentate ligands you have. En is there, OX is there, which is a charged one, which is a anionic one, that is oxalate. So oxalate is which one? C2O4, right? C2O4 whole thrice. Right here, it is what? C2O4, C2O4 thrice, right? Okay, anionic. Okay, so that we made the complex. What is the oxidation state? What is the oxidation state of Fe ion in the complex? Dear all, there are 3 potassium. What is potassium charge? +1. So 3 potassium plus 3. Fe we don't know. X. And oxalate charge is -2. 3 oxalate charge is -6. Overall it's neutral. So X is equal to what? +3 is the oxidation state. So why we didn't consider En ligand? You know, En ligand is a neutral ligand, but they said the ligand should be anionic ligand. So charge should be minus. Ready? Next question. In an octahedral coordination entity, coordination sphere, the metal ion is surrounded by, so metal, let me take it as M. It is connected by 6 fluorine. Okay, let me take it MF6 is the complex. Ready? It's an octahedral complex. Crystal field splitting energy for this complex is delta O. Yes, of course, the CFSC for octahedral complex we express by what? Delta O. Okay, and electron pairing energy is P. You know, pairing energy P. Then which of the following expression is correct about this complex? Dear, fluorine is a weak field ligand. You know, weak field ligand makes less CFSE. Yes or no? So we can write CFSE is less than pairing energy. CFSE, that means delta O less than pairing energy. Delta O less than pairing energy. You know, when a strong ligand approach, the splitting will be more. When a strong ligand approach the central metal atom, splitting will be more, where delta O will be greater than pairing energy. If it is a weak ligand, delta O will be less than pairing energy. Next question. They given a complex here, M, metal is M, AA. What do you mean by AA? It is a bidentate ligand. And X2, there is a 2 monodentate ligand, another 2 monodentate ligand, that is Y2. Ready? Is a type of coordinate compound in which M is metal, AA means a bidentate ligand, X and Y are monodentate ligand. Which of the following isomerism does this compound exhibit? Isomerism part is very, very, very important here. Can it show coordination isomerism? Of course no. Coordination isomerism, if we want to show that the 2 coordination sphere should be there. Yes or no? So it is not possible. What about linkage isomerism? In order to show linkage isomerism, the complex must contain a ambidentate ligand. There is no ambidentate ligand mentioned. Geometrical means what? Cis-trans. Is this compound can show cis-trans? We studied cis-trans isomerism. Since it is an octahedral complex, it shows Ma2B4 type only shows which one? Cis-trans isomerism. It's not that. So only possibility is what? Optical isomerism. Dear, let me just to draw this complex is metal is given there. You know, octahedral complexes, right? So X is there, right? X is there. Then Y is there. Then there is a AA, that is a bidentate ligand. So if you take the mirror image of this complex, of course it will be a non-superimposable mirror image. You know, non-superimposable mirror images are what? Optically active one. So only the possibility is what? Optical isomerism in this complex. Next question. As per the crystal field theory CFT, which of the following is correct about the repulsion between ligand dxy, dyz, dxz orbital in tetrahedral complexes? Dear, you know, in tetrahedral complexes how the d orbitals split? Yes. In tetrahedral complexes, 3 orbitals above, 2 orbitals below. What are the above one? dxy, dyz, dxz. Here is dx square minus y square and dz square. So no, in octahedral it is opposite. So since it is tetrahedral, the orbital dxy, dyz, dxz experience large splitting. Therefore, they go to upper energy, that is having high energy, but it is least stable. So in tetrahedral complexes, dxy, dyz, dxz orbital experience more crystal field splitting energy. Therefore, it's going up. It is more than that in octahedral complex. Yes. Why it is so? In the reason you may study. In tetrahedral complexes, the ligand is approaching what? Between axis. These all orbitals are between axis. So the repulsion. So the interaction will be more and the crystal field splitting energy will be more and they will go to the upper energy stage. Right? Next one. Which of the following coordination compound is diamagnetic? You know, diamagnetic means there is no unpaired electron, right? Has zero unpaired electron and has an octahedral geometry. If they ask like this, I will cut immediately B and D because here coordination number is 4. Coordination number 4 mean no chance to becomes what? Octahedral. Coordination number should be 6, that is octahedral. So here is 6, here is 6. And what we can write? Option C. Because chlorine is a weak field ligand. If there is a weak field ligand, pairing do not occur, there will be unpaired electron. But cyanide is a strong ligand, pairing occur, there won't be any unpaired electron. So option C is the answer. Next question. In an experiment, test tube A, okay, there is a test tube A, they put what? FeSO4, NH4 twice SO4, and we have 6H2O. Dear, what is this compound? You know very well. This is our more salt, double salt. And test tube B contain, the compound is given as K3Fe C2O4 thrice. That is the test tube B contain. It's a coordination compound. On adding few drops of KSCN. What is SCN? You know, thiocyanate. What is KSCN? Potassium thiocyanate. So whenever you add KSCN, okay, to both of them, KSCN, ready? To test tube, solution of one of the test tube turns red in color. One of them giving red color. Identify which out of two solution in the test tube A or B turns into red. Dear student, very carefully listen. Fe, you know, double salt, what is the difference between double salt and coordination compound? That is the point here. A double salt undergo complete dissociation in water, whereas complex undergo partial dissociation. So, FeSO4 breakdown, what do you get? Fe2 plus N, SO4 2 minus. Yes? NH4 twice SO4 breakdown, you will get 2 NH4 plus N, SO4 2 minus. So double salt undergo complete dissociation in water. Dear, this Fe2 plus combined with the SCN minus, Fe2 plus combined with the SCN minus, it form a complex. That is what the red in color. So this complex, the more salt can give the red color with the KSCN. But here, see the Fe, it is inside the bracket, inside the coordination sphere, inside the coordination entity. It do not come out, yes or no? So this Fe cannot react with SCN, so it do not give which one? The red color. Okay, so identify which of the following compound react? This one. Give reason why does one solution. That's the reason we said. Here, it's giving double salt undergo complete dissociation. It giving Fe2 plus ferrous ion. It combined with the SCN form the red color complex. Whereas in B compound, Fe inside the coordination sphere, it do not come out as ion. So it cannot react with the KSCN to give the red color. Next question. NiCN4 2 minus when kept in magnetic field, it is weakly repelled, whereas the other complex weakly attracted. So NiCN4 2 minus, and we have CO, right? Cobalt F6 3 minus. Dear, you know which theory we need to apply here to explain this concept. That is our VBT, valence bond theory. You know, nickel 28, cobalt 27, you can write our step 1 at the ground state, step 2 oxidation state, step 3 ligand, pair or unpair. Here cyanide. Since cyanide is a strong ligand, electrons undergo pairing, so it becomes diamagnetic, right? It will become diamagnetic. Whereas here fluorine is the ligand. Fluorine is a weak field ligand. Weak field ligand. Weak field ligand means no pairing. So there will be unpaired electron. There will be unpaired electron. So the complex will be paramagnetic, right? Paramagnetic. You know, diamagnetic substances are repelled. So that's why they said weakly repelled. So diamagnetic substances are weakly repelled by the external magnetic field, whereas paramagnetic substances are attracted by the magnetic field. That is due to the difference in the ligand, right? Next one, there are two sample solution of complex compound kept in two test tube A and B. Test tube A contain the solution of CONH3 thrice and Cl3. It's a type of Ma3B3, you know, it shows Falkenmer isomer, right? Complex. And test tube B contain the solution of COCl2En twice whole plus. Ready? If plane polarized light, so plane polarized light if they ask means definitely question is based on what? Optical active or not. Okay, which sample out of A and B can rotate the plane polarized light? Dear students, it is a type of Ma3B3 octahedral. We studied the type octahedral. Ma3B3 can show which isomer? Facial and meridian isomerism. But this is a type of Ma2B4. Why Ma2B4? It's a bidentate ligand, right? So Ma2B4 can show which isomerism? The cis and trans isomerism, where cis is what? Optically active. We studied. So it is a unsymmetrical one. So since it is a type of Ma2B4, it can show cis and trans isomerism, where cis is optically active, which can rotate the plane polarized light. So let me draw the shape of the cis isomer. The cis will be, how we place it here? Chlorine, chlorine, then other two side, En, En, whole 2 plus. If you take the mirror image of this one, you will get a opposite one. They are non-superimposable, so they are optically active, so they can rotate the plane polarized light. So answer is this compound B. Next one, 1 mole of an isomer of the complex CrH2O 6 times Cl3 when treated with AgNO3, silver nitrate, it produces 2 moles AgCl, 2 moles of AgCl. Write the formula of this isomer of the complex and show how the metal ligand bonding differ in the two isomers through both are octahedral. Listen very carefully, dear. Very simple question. AgNO3 they reacted, they treated, they got 2 moles AgCl. Remember, if they said 2 moles AgCl mean there should be 2 chlorine outside as counter ion. If they said 3 AgCl formed mean there are 3 chlorine outside as counter ion. So here now present we have 3 chlorine outside. If you directly treat this complex with AgNO3, you will get 3 AgCl because there are 3 chlorine outside. But if you want 2 AgCl, do one thing dear, CrH2O 5 times. Let me put 1 H2O out, 1 H2O out, 1 chlorine in. Okay, what is left? Cl2 and this H2O is a water of crystallization. Whenever you exchanging the ligand from the counter ion and inner, the sphere and all, remember if it is an octahedral complex, remember always 6 ligand should be inner. 6 is the coordination number. Therefore, I put 1 H2O out, 1 chlorine in. So here also 5 plus 1, 6 is there. Okay, so this is the first complex, this is the second complex. See, here 2 chlorine only outside. If you treated with this with the AgNO3, you will get 2 AgCl. So this is our complex. And question is not over. Write the formula, yes, this is the formula of the complex and show how the metal ligand bonding differ. See, here in first complex, chromium metal is bonded to fully with what? 6 aqua as ligand. But in second complex, chromium directly bonded to 5 aqua and 1 chlorine. That is the difference, right? So these are the question. Next one. A complex given as COA4B2 and Br is octahedral in shape. Of course, 4 plus 2, 6 is the coordination number, so octahedral. The oxidation state of cobalt is, we have to get it what? Plus 3. When this complex is treated with AgNO3, when this complex treated with AgNO3, it gives 1 mole yellow precipitate of AgBr. Only 1 mole AgBr. What do you mean by 1 mole AgBr? There should be only 1 bromine outside. Yes, we have only 1 bromine outside. Okay, good. Based on the above information, show what is the denticity and charge on the ligands A and B. Give reason for it. A simple question, but we have to take care. See here, what is the denticity of this one? See here, this cobalt, what is the charge given? +3, right? +3. So cobalt is +3. So what should be the charge of A and B? You know, bromine charge is already -1. So let me put the charge of one B ligand is -1. And A ligand charge, let me take it 0. Then you check it. Cobalt X, okay? Cobalt X. The ligand I'm taking as the charge is 0. B ligand charge is -1. So 2B is there, therefore -2 plus Br is -1. You see here? Yes, you will get it as what? +3. So I can write that A is neutral. A is neutral ligand and B is what? It's an anionic ligand. Its charge is what? -1. Then only overall cobalt you will get +3. Yes or no? And one more question. So charges of A and B we got it. What is the denticity? See here, A is a monodentate ligand, B is also a monodentate ligand. Why? Because A giving 4 bond and means 4A giving 4 bond, 2B giving 2 bond. That means each ligand giving 1 bond, right? 1 coordinate bond with the metal atom. So that is the denticity 1. Both are monodentate ligand. Okay, then next question. So this is over, right? Next one. A coordination complex compound of Cr3 plus is homoleptic. What is mean by homoleptic? It is connected to only one type of ligand and optically active. Okay, draw the structure of the optical isomer of the compound. If the general formula, what is the general formula of given metal? A thrice all 3 plus. Can you give me an equation for a complex with the Cr3 plus? Metal already they said it's chromium. What is the ligand you take it? It's a bidentate ligand. You have 2 bidentate ligand. One is En and one is OX. Which one you select? I will select En. I will select En. Okay, the other also fine. That En 3 plus. So here chromium charge you check it all. Chromium X, En is 0 and overall is +3. Yes, chromium is +3 charge. Ready. That's everything is okay. Question. Were metal and chromium and AA is a bidentate ligand. Metal is chromium, A is a bidentate ligand. Ready. Question is that draw the structure of the optical isomer. Okay. How to draw the optical isomer of this one? Cr. Since it is an octahedral complex, what we can place it? Right. This one is the octahedral shape. How can we place it here? That's one En, second En and the third En. Overall charge is what? 3 plus. When you take the mirror image of this one, of course, we will get a non-superimposable mirror image, right? This En come to left side, this En go to right side, this En again left side. See, they are non-superimposable mirror images, so they are optically active also. Right. Next one. First complex and second complex are 2 octahedral complexes of cobalt. First one, which one of them will have less crystal field splitting? Dear, in the first complex, who is the ligand? NH3. And second complex, which is that H2O. Here cobalt charge is what? Here cobalt charge is what here? Cobalt 3 plus. In this case, cobalt charge is what? 2 plus. And here is a strong ligand, here is a weak field ligand. Who make more or which of one of them will have less crystal field splitting energy? Less crystal field splitting energy for the second one. Because, you know, the stronger the ligand, greater the charge on the metal and all, make more crystal field splitting energy than the weakest ligand. Which factor influence splitting of d orbital in these 2 complexes? Many factors are there affecting the crystal field splitting energy difference. A strong ligand when approaches, the crystal field splitting energy will be more. If a weak field ligand approaches, it will be less. Greater the charge on the central metal atom, the crystal field splitting may occur more. Lesser the charge, less splitting. So both of the factor can be applied here. Have you seen this diagram in your textbook, dear? This is our metal carbonyl. You know, metal when bonded with the carbonyl as ligand, there is a formation of sigma and pi bond. Normally, the metal ligand bond is a sigma bond, single bond, but carbonyl ligand have an ability to form a double bond with the metal. That's what that called a synergic bond, right? Synergic bond. So, dear, the question is, answer the following questions to describe the bonding in the metal carbonyl. Question number 1. What type of bond is formed by the donation of lone pair of electron in CO with the central metal atom? Can you just explain how the sigma and pi bond is formed? Let me explain here. The sigma bond, generally every ligand make metal what sigma bond. How it is? Generally sigma bond is formed by the overlap between the empty d orbital of the metal atom, empty orbital of the metal with filled orbital of the ligand. So you see, donation of lone pair of electron CO to the central metal atom. So that means the ligand is in richer in electron, ligand having filled electron. The filled orbital electrons are giving to the central metal atom the vacant d orbital. That is the formation which bond? Sigma bond. So sigma bond is formed by the overlap or the interaction between how it is forming here. The filled orbital of the ligand with the vacant orbital of which one? Metal. What about the second one? What type of interaction between metal and CO ligand creates a synergic bond? The extra synergic bond, how it is preparing? Just opposite. It is formed by the, answer I am saying, okay, it is formed by the interaction between the filled orbital of the metal with vacant anti-bonding pi star orbital of the ligand, right? So that is what the synergic bond. And how is delta O value affected by the CFSE value affected by the interaction of CO ligand and metal ion in metal carbonyl? Have you seen the spectrochemical series, my dear? The weak ligand, strong field ligand, the arrangement, which is the last one, which is the strongest ligand, that is carbonyl, CO. CO is the strongest carbonyl ligand. Stronger the ligand, crystal field splitting energy will be more. So that's a concern about metal carbonyls. Next question for you, dear. In an unknown complex, MX4, the oxidation state of central metal is 0. It is in 0 oxidation state. Okay, 0 oxidation state. If in an experiment, so this ligand should be neutral charge, right? If in an experiment metal M is found to be nickel, okay, metal M is nickel, then predict whether the ligand X in the formula will be CO or Cn. Of course CO, because if you want to get the metal charge overall 0, this charge of the ligand should be 0, which is a carbonyl is a neutral ligand, but cyanide is -1 charge ligand. So the complex is NiCO4. Check it all of you. Nickel charge X, carbonyl is a neutral ligand, overall 0, yes, X equal to 0. What about if it is Cn? It will get +4, right? Because Cn charge is -4, overall you will get +4. Okay, complex, justify your answer and predict the shape of the molecule. You can predict the shape of the molecule by using which one? The VBT. So dear, nickel is the central atom, nickel is 28. That is what? Argon 4s2 3d8, we can write it. Here nickel charge is 0, so nothing to lose here. So this is 3d8, right? 3d8, let me write 1, 2, 3, 4, 5, 6, 7, 8 and 4s is 2 electron. Ready? This is 3d and this is 4s. And what is next one? Next one is who is the ligand? Carbonyl. Carbonyl, since it is a strong ligand, it's make pairing. So all the outermost electron come inside and get paired. So d orbital will be fully paired. Yes or no? D10 will be the configuration. So 3d is gone. What is left here? 4s is there. After 4s, you have 4p. Ready? Total how many ligand? What is the coordination number? If 4 is the coordination number, 4 vacant orbital we have to mix it. 4 vacant orbital we have to mix it. So what is hybridization? sp3. sp3 means what is the geometry dear? Tetrahedral is the geometry. Okay, tetrahedral is the shape of the molecule. Next question. When AgNO3 solution is added into a solution of coordination compound, this one, what is the complex formula given? PdCl2 4NH3. Ready? It produces 2 moles AgCl. When this react with the AgNO3, they giving 2 moles AgCl. Dear, 2 moles AgCl produced means what is the meaning? There should be 2 chlorine outside. So what is the formula? PdNH3 4 time, put the 2 chlorine outside, then only it will give you 2 AgCl. Okay, so this is our complex. Question: on the basis of the information above, designate coordination entity. What is the coordination entity? Coordination entity means coordination sphere. What is the coordination sphere here? Answer is Palladium, NH3, 4 time. What is the overall charge? 2 plus, right? This 2 plus here. Okay, who is the counter ion? 2 chlorine. 2 chlorine is the counter ion. Coordination number of the central metal. What is the coordination number? Since amine is a monodentate ligand, one amine provide one single bond, so 4 amine provide 4 bonds. So coordination number is 4. What is the oxidation number of palladium? Palladium is X, amine is 0 and 2 chlorine charge minus 2, overall 0. So X is equal to what? Plus 2. So this way, simple questions we can expect it, but much more concentration is required while taking the things. So hope you clear. Coordination compound, the competency based question. Just go for your 2025 chemistry board exam. Just rock it.